Hello, and welcome to Learning Beyond Limits, where learning has no limit. Today we're going to talk about the number system. In our previous video, we spoke about the number system and we specifically spoke about the base 10 system. That video was an introduction to this video. So if you want to see that video, follow the subscription below and make sure you don't miss that introduction. In our previous video, we spoke about the base 10 system where we understood that there are 10 symbols that are used in the base 10 system to represent amounts. And those symbols are from 0 to 9. So we can represent 0, which is nothing, or the idea of nothingness, and 1, 2, 3, all the way up to 9. When we get to 9, if we want to represent 1 more than 9, then there is no one single digit number in the base 10 system to represent the concept of 1 more than 9. So how do we do this? I'm going to introduce to you a unique idea. Using this scenario, let's say we have an airport, and at this airport, the technology is down. All communication to the air is down, so the communication center cannot communicate to the planes in the air to let them know that the landing strips, and these are the landing strips that I'm drawing right here, the landing strips are full or whether they're empty. And we do know that there are 100 planes in the air and they need to land. To do this, the airport will be utilizing these LEDs that they have, and they have a strip of LED on a pole, or we can just call them light bulbs on a pole, and there are 9 on this side and there are 9 on this side. Now the control center could go ahead and light the LED 1, 2, 3, 4, 5, 6, 7, 8, 9, and that would show that there are 9 planes now on the ground, and they could keep going 10, 11, 12, 13, 14, 15, 16, 17, 18. But if they do it that way, they can only represent 18 planes landed on the ground. So the solution to this then is to use the base 10 system. And so we have 9 LEDs over here and 9 LEDs over here. So we're going to use the position where each of the LEDs are to present a value to the LED. So all the LEDs over this side, we're going to consider them as 1s. And the ones over this side, we're going to call them 10s. And so now we can go ahead and we can signal that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 planes are now landed in the parking lot on the ground. And when we have one more plane landing on the ground, look at what we're going to do. We're going to turn off all the LEDs over here, or all the lights over here we're going to turn off, and we're going to turn on this light to show that we have one group of 10 and no ones. So that represents 10 planes on the ground. And if we keep going, we can say, well, we now have 11, 12, 13, 14, 15, 16, 17, 18, 19, and we turn off all the lights on the ones column again and turn on 2 over here to show that we are now at 20. And if we go further, we could say 1, 21. And to represent this, to write this, it would be easy as saying 2 groups of 10 and 1, 1 right. With that, we can see how we use the place value and the position of the number to give the value to the concept and the idea of 21. So we know that 21 would be 2 groups of 10. That would be one group with 10 things inside, and this would be another group with 10 things inside as well. And this is a single one outside by itself. So we could very well use the 10s and 1s column or chart ones over here and tens over here. To represent, let's say we're talking about the number 23, then we can write it on our chart as 2 tens and 3 ones. And if we were going to add 14 to 23, we can also represent that on our chart. We can say 1 10 and 4 ones, and we can now go ahead and add that, put our addition sign, and we will get 7 and 3. So we have 3 groups of 10 and 7 ones, and we'll be talking more about adding in base 10 in our next video. So subscribe to this channel and click like. Also, leave us a comment in the comment section below. And remember, this is Learning Beyond Limits, where there is no limit to learning.